Peatlands. Peat is a soil layer that consists of partially decomposed organic matter, mainly derived from plant material, which forms under conditions such as waterlogging, oxygen deficiency, high acidity, and low nutrient availability. It is mainly formed from small plants like herbs, shrubs, etc. The Waikato region is famous for its fertile soil and productive farmland. This region, among the other regions, has the largest area of peat in New Zealand. Peat is highly fertile and is used as a productive growing medium, helping to increase the moisture holding capacity. These soils are drained and cultivated. Farmers use peatlands for pasture and crops, cultivation and fertilization, land development, and infrastructure. Though they have substantially improved farmers' ability to utilize land profitably, it nevertheless leads to irreversible damage, such as loss of wetlands and the release of carbon into the atmosphere, playing a role in climate change. In many areas, this drainage of peat has started to bring about issues like cracked soil, water management issues, climate change, etc. By adjusting and changing certain methods and looking for alternative ways would significantly improve current conditions. In this video, we will take a closer look at the problems arising from drained peatlands and potential mitigation strategies, along with implications for land use. Without further ado, let's dive into it.
When peat is drained, it sinks down. This is called subsidence. Peat can hold up to 20 times its weight in water, so without that water supporting its weight, it compacts. This then squeezes out even more water, causing more compaction, in a process called consolidation. This is the main cause for peat subsidence. However, the biological decomposition of peat also contributes to its subsidence. Peat is able to build up layers due to its harsh environment, which is hard for many decomposers to live in. So, creating an easier environment for them to live in speeds up the decomposition of peat, causing it to shrink and adding to how much it subsides. When peat is cultivated for farming, this harsh environment is mitigated in order to grow crops or pasture. A large factor in cultivating peat is the introduction of oxygen into a previously saturated soil. This happens from both draining and cultivation practices, like tilling. Tilling breaks the peat into smaller pieces, which makes it easier to decompose, as well as adding oxygen to the soil. More microbes can survive with oxygen than without. Oxygen also allows insects and worms to move in, so oxygen speeds up decomposition, adding to subsidence. Other cultivation techniques for peat are to add lime and fertilizer. Lime neutralizes the usually acidic soil, and adding fertilizer increases plant life. Both of these make peat more hospitable for decomposers. So, peat subsidence is caused by both the mechanical process of consolidation and the biological process of decomposition. Another important result of this increased decomposition is the creation of carbon dioxide, a greenhouse gas that can stay in the atmosphere for hundreds of years. Peat is mainly made up of layers of partially decomposed plants. This means it is extremely rich in carbon. In fact, it holds onto more carbon and for a longer time than forests do. When peat is decomposed, that carbon gets released to the atmosphere, where it bonds with oxygen to become carbon dioxide. Peat is a unique soil. It's the only organic soil. It can hold up to 20 times its weight in water, providing flood protection and drought preserves. It's a natural water filter, it's an extremely effective carbon sink, and it hosts a very unique ecosystem. In fact, Waikato's wetlands have some plants and animals that are only found here, in Waikato. Since the late 1800s, about 80% of the Waikato region's original peat has been drained. This is why it's important to incorporate mitigation techniques in farming to preserve the peat we have left.
I am going to introduce you to 3 ways of the mitigation of the CO2 emission and subsidence. First way of mitigation is water table management. I am going to introduce 3 ways of water table management this time. First way is to use shallow drainage systems, which help maintain a higher water table. One of the biggest challenges in peatland management is excessive drainage. When peat dries out, it becomes hydrophobic and then difficult to re-wet. This leads to the formation of cracks. Over time, rainwater escapes through these cracks, flowing deep into the subsoil and becoming unusable to crop. Equally important is maintaining water levels during drier months. Without enough moisture, soil degradation accelerates. One effective solution is installing weirs in drainage channels. Third way is to fence drains to exclude stock. Most silt in drains comes from stock damaging the drain banks. Next, reducing soil disturbance is important for not increasing the emission of CO2, because disturbing the soil too much makes peat break down faster, releasing CO2 into the air. So, limiting deep tillage mitigates it. Finally, avoid heavy machinery because they press down on peat, damaging its structure and making it sink faster. So avoid using too heavy machinery or use less often. It can slow the rate of subsidence. However, these options have trade-offs. Less soil disturbance might lead to more weeds. Avoiding heavy machinery might lead to the need for more labor.
Now I want to talk about the implications for land use. First is economic and environment impacts. Before we look at the damage, let's briefly talk about mitigation. Efforts to restore peatlands. Mitigation can help by reducing carbon emissions and bringing back some natural functions, but it is also challenging. It's costly, slow, and some damage, like biodiversity loss, can't be fully reversed. Now, what happens when we dry peatlands? At first, it seems helpful. More lands for crops, more income. But over time, the land shrinks and sinks, damaging soil, roads, and drainage systems. Fix this is expensive. Farmers face higher costs to keep the land usable. Environmentally, it is worse. Habitats are destroyed, biodiversity declines, and carbon dioxide is released, which speeds up climate change. So short-term gain often leads to long-term loss for both people and plants. Then let's talk about the cultural impacts and final message. The loss isn't just economic or environment. It is also culture. For many indigenous communities, peatlands are sacred. They hold deep history, identity, and spiritual meaning. When these lands are joined, cultural heritage and traditional ways of life are lost. So what can we do? First, support indigenous knowledge and cultural projects. Second, involve local communities in land use decisions. They know the land best. Finally, find solutions that protect both nature and culture together. In the end, protecting peatlands means protecting the environment, the people, and the future.
To conclude, peats are an asset to the ecosystem as they support agriculture and protect biodiversity. However, draining of peats for short term economic benefits has led to serious long term environmental damage. By adopting proper land management techniques, it will be possible for us to restore our damaged lands. Working for the betterment of both nature and humans is essential for a sustainable future.